Alrighty, lesson 1.2 is more simplifying basics. So this section will focus a lot more on exponents. We'll deal with a little bit with scientific notation and then end with polynomials. And those happen to be our three main objectives for this lesson. So throughout this course, when we work with exponents, we may need to be combining things that have exponents in them. So there's a couple of properties that we're going to make sure we are aware of. So the first one says, okay, let's say I have x raised to some power times another x raised to a different power. There is a rule that says I can combine them as long as they have the same base, so x, and the exponents will be added together. So for example, if I had x to the fourth times x to the fifth, according to this property, I would now have x to the ninth. There's another property that says if I have x to the m divided by x to the n, this is going to be the exact opposite of the rule we just did. So x, and we would subtract the exponents. So if I had, for example, x to the seventh over x to the fourth, according to this property, I would now have x cubed. I subtract the exponents. The next property is kind of goofy, and it seems like one of those things someone just made up, but there is reasoning behind it. Anything to the zero power, I don't care what the base is, if it has a zero exponent, the answer is always 1. And I'll go over why in just a moment here, because I want to talk about this next property. So if I saw 7 to the 0, that's 1. If I saw negative 80 to the 0, that's 1. I don't care what's inside. If it has a 0 exponent, the answer is 1. Another rule we're going to run into is, what if the exponent is negative? Well, mathematically, that is the same thing. So right now it was up in the numerator. That is the same thing as moving it to the other side of the fraction, but it turns positive. So for example, if I had 2 to the negative 3, that is the same thing as 1 over 2 to the positive 3. Now, the reason why those rules work, because that, again, those seem like someone just made them up. I want to quick show you here. So if I did a little pattern, if I had 2 to the fourth, well, that's 16. If I had 2 cubed, that's 8. If I had 2 squared, that's 4. If I had 2 to the first, that's 2. So then if I asked 2 to the 0, well, look at this pattern here that we've kind of developed. Every time I decrease the exponent, it's like I'm dividing by 2, dividing by 2, dividing by 2. So if I took 2 divided by 2, I would get 1. Anything to the 0 power is 1. Well, what if I kept going? What if I wanted 2 to the negative 1? Well, according to the property we just wrote down, that is the same thing as this. 1 over 2 to the positive 1, which is 1 over 2. And it fits with our pattern. If we kept dividing by 2, 1 divided by 2 is 1/2. If I wanted to do 2 to the negative 2, using our property, we know that's 1 over 2 squared, which would actually be 1 over 4. And it makes sense. I'm dividing by 2. So it doesn't seem like those properties should work, but mathematically they do make sense. The next rule I want to write down is kind of the opposite of the one we just did. if I have 1 over x to the negative n, so let's say it's a negative exponent, but it's already in the denominator, well, just do the opposite then. To turn the exponent positive, we'll bring it up. So for example, if I had 1 over x to the negative 5, that is the same thing as x to the 5th. Mathematically, they are the same. A couple rules left. If I had x raised to some power, and then there was another power outside, they multiply together. So it would be m times n. And the last rule, if I had, let's say, something being divided, and it was raised to an exponent, so the whole entire quantity is being raised to n, that is the same thing as saying, okay, x to the n and the y to the n. They both get it. So let's try some examples of these to see if they make a little more sense. So I want to simplify these as far as I can. These are exponential expressions because we're dealing with exponents. So these first two guys, I want to multiply them together. So let's focus on the numbers first. 6 and 5. They multiply together, and I get 30. Next, I have the x's. So if I want to take x to the 4th times x squared, if we look back at our properties, x to the 4th times x squared, that's this first property. So I add the exponents. And then finally the y's. We'll do the same thing for the y's. So I want to take y cubed times y to the 7th. So again, I'm going to add the exponents and I get y to the 10th. Now, a common mistake that I will often see is people want to multiply the x and the y together and write it as a 16. You can't do that. Those properties don't work there because they are not the same base. So this is as simple as my answer gets. Okay, let's try the next one. This time I'm dividing, so let's start with the numbers first. 30 divided by 5. We get 6. Now let's do the x's. X to the 12th divided by x cubed. So if I want to divide those, if I look at my properties, it's this second one. If I'm dividing, I subtract the exponents. So 12 minus 3, I get x to the 9th. And then I do the same thing for the y's. And that's it. I cannot combine the x's and y's because they're not the same base. So there's my answer. Now, what should stand out on this next one, we have a 0 power. So you might think, oh, the answer is 1 because anything to the 0 power is 1. Well, yes and no. The 0 was only for the x. There's still the 5 there. So it really becomes 5 times 1 because the x to the 0 is 1. So this answer is 5. Now the next one, this is why I put these next to each other in the notes. The next one, the answer is just 1 because the entire thing was raised to the 0. Those parentheses are very important. If the previous one, if they would have written it like this, that would have just been 1 because the entire thing was raised to the 0. So watch out for that. And this next example, 9 to the negative 2, since I have a negative exponent, to turn it positive, I'm going to use the property that says we just move it to the other side of the fraction. And now I just need to do 9 squared. So 9 times 9, this answer is 1 over 81. Okay, next one. I have another negative exponent. So just like what we did on the previous one. Now notice when it moves, it's the exponent that changes signs, not the base number. It's still negative 2. And now I just need to do negative 2 to the 5th. So negative 2 times negative 2 times negative 2 times negative 2 times negative 2. So we get a negative 1 over 32. Okay, next one, I have a negative exponent, but it's already in the denominator, so I'm going to move it the other way. And it'll become 6 squared. So 36. Okay, now look at the next one. The next one technically has 3 parts to it. There's the 7. And then there is the x to the negative 5th, and then there's the y squared. So only one of those has to move, the x to the negative 5th. So the 7's going to stay put, and so is the y squared. But the x to the 5th is moving to the denominator because it had a negative exponent. I cannot subtract the 2 and the 5 because they're not the same base. So that is my simplified answer. Okay, the next one. Notice we have an exponent and then outside another exponent. That is this property. So we multiply our exponents. 5 times negative 3, I get y to the negative 15th. And then I would like you to write that with a positive exponent. So we move it. So my answer would be 1 over y to the 15th. Okay, next one, same thing. We're going to multiply our exponents. Negative 4 times negative 2. And that one is done. It's a positive exponent, so I'm not going to move it. B to the 8th. Okay, next set. Again, I have an exponent on the very outside, but notice this time there's multiple things in here. So when I take the exponent in, you need to think of it, the negative 2 gets the 4th power, and so does the y squared. It's like they're both getting the 4th. So let's do negative 2 to the 4th. So negative 2 times negative 2 times negative 2 times negative 2 would be a positive 16. And then I multiply my exponents for the y, so I get y to the 8th. 16y to the 8th. If you're typing this guy in your calculator, if you do it without the parentheses, chances are good it will say negative 16. That is wrong. Because literally what it means is this. So we need to tell it to include the negative. An even number of negatives should come out with a positive answer. Okay, next one. Let's deal with that negative 3 first, so they're all going to get it. So let's 2 times negative 3, I'd have x to the negative 6. And then the y would also get the negative 3. Everything's getting it. Now we have a whole lot of negative exponents. Let's turn them positive. So the 4 to the negative 3 has to move down. The x to the negative 6 has to move down. And this guy's going to move up. That's how we're going to turn the exponents positive. So I'll now have a y to the positive 3. And in the bottom, I'll have 4 to a positive 3 and x to a positive 6. And then the last thing I'd want you to do is tell me what 4 cubed is. 4 times 4 times 4. So our final answer would be y cubed over 64x to the 6th. 4 cubed is 64. Okay, next one. Everything's going to get that cube, so negative 3 cubed. And then I have x, we multiply our exponents, so 4 times 3, 12. And then the y, 5 times 3, 15. And the last thing I'd want you to do is actually tell me what is negative 3 cubed. So negative 3 times negative 3 times negative 3, get negative 27. Whoops. Nothing has to move because there's no negative exponents. Okay, next one. Let's do our division. So negative 35 divided by 5, negative 7. So let's subtract 2 minus 6, right? We're subtracting for the x's. So 2 minus 6 is negative 4. And then let's subtract for the y's. So 4 minus negative 8. 4 minus negative 8. That's really plus. Two negatives make a positive. So I get y to the 12th. And then I don't want negative exponents in your answer, so the negative 7 is okay because that's not an exponent. But the x will now be in the bottom to a positive 4. The y to the 12th is still up top. So that would be my answer. And the last one here, we're going to multiply those together. So negative 7 times negative 2 would be 14. And now I want to do the x's. So technically this x is to the first. So what do I do with the exponents when I'm multiplying? We add them. So 1 plus 5, x to the 6th. And then I want to do the y's. 4 plus 6. Nothing has to move because I have positive exponents. We will be working with these exponent properties a lot throughout the semester, so we want to make sure we get those down. All right. The next thing, I debated about including this, but I think it's better to quick talk about it. We won't see this a ton, but there are some answers throughout the semester that will be written in scientific notation, so I just want to touch on it quick. So scientific notation is basically a way to represent numbers that are either really, really big or really, really small. And they're always in this form, where this A represents a number between 1 and 10 or negative 1 and negative 10. So write each number in decimal notation. So all this means, this is saying, hey, this number has a lot of decimal places. It has 7 of them. So all you're going to do is you're going to take your negative 6.2, and from the decimal, we are going positive 7. So 1, 2, 3, 4, 5, 6, 7. So these all become zeros. So this answer written out is, let me write it up here and then we'll put my commas in. So it's negative 62 million. So scientific notation is just shorthand. The next one, now this time it has a negative exponent, so we want to go left. So here's my number. From the decimal, I'm going to go 1, 2, 3. So this answer becomes 0.002019. So this is a small number. Okay, and now let's try the bottom two. Write each number in scientific notation. So this big number, currently the decimal point is right here. So we're going to start moving the decimal back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You want to move the decimal until the number is between 1 and 10. So my answer would be 3.497, you don't have to write the zeros, times 10, and now how many times did I move it? 13 times. So that represents that large number. And now let's try the other one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm moving the decimal until the number is between 1 and 10. So 8.02 times 10 to the negative 11, because it's representing a small answer. Okay, hopefully that's pretty basic. The last objective for today is we're going to be dealing with something called polynomials. I'm not going to go into too much detail about them because they get their own unit. For now, we're just going to simplify them. So perform the indicated operation and write your answer in standard form. We'll talk about that. So notice the operation between them, addition. Someone asked me once, why do the parentheses need to be there if we're just going to add them? All the parentheses are here for is telling you that, hey, this is one polynomial and this is the other polynomial, and I want to combine them into one. So we're just going to combine like terms. So I have negative 9x cubed and 13x cubed. If I add negative 9 and 13, I get 4x cubes. Then I have my squareds. So 7 plus 2, I have 9x squared. Then I have my x's. Now careful, they are negative. So negative 5 plus negative 8, negative 13x. And then finally I have the constants, 3 and a negative 6. So 3 plus a negative 6 would be a negative 3. Standard form means your answer is written in decreasing order of the exponents. So 3, 2, 1, and none. That's what I want by standard form. So this is the answer, the combined polynomial. If it asks for the degree of the polynomial, the degree is the highest exponent you see. So this has a degree of 3. Down the road, we'll talk about the importance of the degree. For today, just be able to spot it. Let's try the next one. This time, notice I want to subtract. So let's start with my cubed terms. So 7 minus 2, 5x cubed. And now let's do the squareds. Now careful here, we have a negative 8 minus a negative 6. Negative 8 minus a negative 6. So that's really plus. So negative 2x squared. Then I have a 9. I don't know why it's not changing color there. A 9x and a negative 3x. But remember, we're subtracting. So 9 minus negative 3. So plus 12x. And then finally, negative 6 and 9. Negative 6 minus 9. Negative 15. It's written in standard form, decreasing order of the exponent, and this also has a degree of 3. That's the highest exponent. All right, the next set, now notice here the operation between them, if they're written right up next to each other, this is multiplication. We're going to multiply them together. Now, if you think back to the math classes you took in high school, when you have two terms and two terms, we will often use something called foiling when we multiply. I'll write out what it stands for here. So when I FOIL these, it's just a way to multiply them. So F stands for first. So I'm going to take my first terms in each set and I'm going to times them together. 3x times 5x would be 15. And if I'm doing x times x, remember I add the exponents. So 15x squared. The O stands for the outer terms. So the very outer terms, the 3x times the negative 3. So 3x times a negative 3 would be negative 9x. I is the inner, so the inside two terms, 4 times 5x would be 20x. And then L is last, the last terms of each. So the 4 times the negative 3, negative 12. The last step would be to combine any like terms. Well, I only have one squared term, so 15x squared. But I do have a negative 9x and a 20x. So negative 9 plus 20 is 11x, and then my minus 12. So there is my polynomial. If they asked for it, the degree is 2. That is the highest exponent. Okay, let's try the next one. We're going to FOIL it. First times first, 7x times 4x. So 28, and it's going to be x squared because I add the exponents, because I had a 1 and a 1. Outer, so 7x times a negative 3 would be negative 21x. Inner, negative 5 times 4x, negative 20x. And last, negative 5 times negative 3 would be 15. So if I write my answer, I have 28x squared. Combine my two like terms, so negative 21 and negative 20 is negative 41x plus 15. There's my polynomial. Again, this has a degree of 2. That is the highest exponent. Next one. I'm going to FOIL it. First times first. So 2y cubed and 2y cubed would be 4y, and remember I add the exponents. So 4y to the 6th. Outer, so 2y cubed times 5 would be 10y cubed. Inner, negative 5 times 2y cubed would be a negative 10y cubed. And last, negative 5 times 5 would be negative 25. If I write my answer, I'll have my 4y to the 6th. Now this time when I combine my like terms, the cubes, they cancel. And then I still have my minus 25. This one would have a degree of 6 because that is the highest exponent. Almost there. Now the next one, I cannot FOIL because this has 2 terms. But the back one has 3 terms. So probably the easiest way to do this is we're just going to manually distribute. So I'm going to take my 2x and I'm going to distribute it in to all 3. So 2x times x squared would be 2, and then remember I add the exponents. So x to the first and x squared would be x cubed. Then 2x times the 4x. So 8x squared, because I add the exponents, and then 2x times 5, 10x. Now I'm going to do the same thing for the 3. I'm going to distribute the 3. So 3 times x squared, 3 times 4x, and 3 times 5. The last step, just like what we did on the others, is to combine any like terms, and let's write it in standard form. So my highest guy is going to be 2x cubed, and there's nothing to combine it with. Now let's do the squareds. I have 8x squared and 3x squared, so 11x squared. Now let's do the x's, 10x and 12x. So 22x, and then my constant, 15. The degree on this polynomial would be 3. That is the highest exponent. All right, the next one, we call these in my class, we call these the dirty dog because they have a tendency to trip you up. What I recommend doing, see how it's squared? To make sure you do the multiplying right, I would write it twice because that's technically what the squared means. There's 2 of them. Can I FOIL on this problem? Well, let's see. There's 2 and 2. So yes, let's FOIL it. First times first would be 9x squared. Outer and outer, 3x times 7 would be 21x. Inner and inner, 7 times 3x would be 21x. And finally, last times last, 7 times 7 would be 49. So I get 9x squared plus 42x plus 49. Degree of 2. All right, one more. Can I FOIL it? Well, let's see. 2 terms and 2 terms, so yes, I can FOIL it. So first times first, x times 3x would be 3x squared. I add the exponents. Outer times outer. Now, x times a negative 5y. How would we write that? Well, you can't really do a whole lot with it. You can write it as minus 5xy, or you can say negative 5yx. The order doesn't matter. I usually write it in alphabetical order. Inner times inner, so 4y times 3x would be 12. And again, I'm going to say xy. And then last times last. So 4y times negative 5y. Negative 20y squared. And now let's combine like terms and we'll have it. So 3x squared. If I combine my xy's, negative 5 and 12, I have 7xy and then minus 20y squared. Now the degree on a type like this, if there's multiple variables, we're not going to mess with, so you don't have to worry about that. The last one, just to make sure, be careful. A lot of people get so carried away with multiplying. Always first look at the operation between the two polynomials, because it won't always be multiplying. So this one wants us to subtract, like what we did at the start. So let's start. 5x cubed and 3x cubed. 5 minus 3. 2x cubed. Now let's do, this is an x squared y. Oh, perfect. I have another x squared y. So negative 9 minus negative 6. Negative 9 minus negative 6. So it'd be negative 3 x squared y's. Now let's do the xy squareds. So 3 minus negative 2. So 5xy squared. And then negative 4 minus 3 would be negative 7. There would be my result. All right, that's all I have for this unit.